Morning. So today we're going to look at the Carver M500t. This was brought to me by the same gentleman that brought the Harmony card that I just did a video on. I said it's not working, so the power's up, but it doesn't seem to pass any audio. So we'll take a look and see what's going on with this. But before we do, I want to take a moment and thank everybody for the wonderful comments you've left on my page. I never really set out to have a YouTube channel. I belong to an audio forum, and I put a video up to demonstrate, I think, how to measure amplifiers using different oscilloscopes. I didn't think much of it, and one day I went to the YouTube channel and there were 75 people who had subscribed, and I was a little shocked at that. So I decided, well, I should probably put a few more videos up. I have 75 people that are looking for something, and that's how it started. There are probably dozens, if not hundreds, of electronic channels on YouTube. And that was one of the reasons I didn't think I really needed to start yet another one. But then I remembered when I was first learning about electronics, I was going to a vocational school, and I would get books and read, not to get ahead of the class, but read about the same things we were learning about as presented by different points of view. And I found that if I didn't understand what we were learning in class from the book, one of these other books might just use a few key words that just made the dots connect. So with that in mind, I thought, well, maybe we could stand yet another YouTube electronics channel. So I decided to start making videos. And as I said, the feedback has just been humbling. I can't thank you enough. Anyhow, I also want to point out, as I've pointed out in other videos, that while these are fairly short, I sometimes spend hours chasing my tail, running up blind alleys. And I do mention it, I hope, but maybe not enough. I don't want you to think I can open these up and fix them in 15 minutes flat without making any wrong guesses. You can see from the previous video, I don't always guess correctly, but we take and make our most educated guess as to what the problem may be, and the key is not to fixate on that, because you may be wrong. It may be something else. And if you fixate on a single idea and say this is what the problem has to be, you can therefore chase your tail for a long period. So gain your experience, look at something, make your best educated guess as to what the problem may be, and if it doesn't look like it is, move on. You can always come back, but chances are if you move on, you'll find the real problem. So without any further jabbering here, let me stop this and let's see what this thing's doing or not doing. Okay, so I've got this guy hooked up to the distortion analyzer and the scope like I do with all the equipment that we get across the bench here. And I'm going to turn the amplifier on. I am feeding signal from my signal generator right here, putting in about 500 millivolts. By the way, that is not terminated, and it puts out peak to peak volts. So it's somewhere in the neighborhood of maybe, who knows? I don't really care. We don't care about absolute value. I just put in enough signal to get a stimulus into my amplifier. I can always turn it up, turn it down. Anyhow, let's turn it on. And we get a whole lot of nothing. Now the amplifier meters aren't moving, the lights are on, they're kind of dim, but I think that's just the nature of the lights on this thing. Let's take a look at the front real quick. I'm not sure whether you can see this, but the meters haven't moved at all. Let me just tilt this up. And we still have signal going in here. So I'm going to take the cover off and we're going to check the power supply, see if we have a problem there, and then take it from there. All right, the first thing we're going to check here is the power supply. Whenever you have something that's totally dead, it's a good starting point. So we have a positive 40 volt here, negative 40 volt there. We have a positive 74 here, a negative 74 here. Then we have a couple of voltages that I really don't care about unless these aren't working. If these are working, we don't care if this is working or this, because we know it is. This goes directly to this optocoupler here. And if this isn't firing, none of the power supply is working. This is an optical isolator. It's a light emitting diode that shines onto the base of a photosensitive transistor. More light, harder the transistor turns on. They're great because light provides excellent electrical isolation. That's the reason they use optocouplers. So we're going to take a look at these and see if we have voltage there, and if we don't, we'll start looking at the power supply. If we do, we're going to start looking at the output stages to see if we have offset that may be keeping it in protection. Okay, so I have the amplifier on now, and now that I have it stood up on its side, you can see that the meter lights are illuminated. So we know at least part of the power supply is working. Now, I always use this extender even though I'm not going to be going deep in anything because it's insulated all but the tip. And you don't want to short anything out. The easiest place to check for our positive 40 and negative 40 are the collectors of the output transistors. So if I look here, I have my negative 40 on the PNP and I should have my positive 40 on the NPN. And we do. So we know the first two voltages are good. Now, there are filter capacitors that we need to take a look at to get our 74 volts. And they are 80 volt at 2200. And they're going to be up near the top here. So that's 74 volts here. I'm sorry, was that negative? Yes, negative 74 volts, positive 74 volts. So it looks like our power supplies are up and running. So next thing we're going to do is we're going to take a look at our output stages to see if we have any shorted transistors giving us offset and keeping this amplifier protection. Alright, so I'm going to take my negative lead going to my meter and ground it to the chassis. And with these emitter resistors, these are dual emitter resistor blocks, which is why they have 3 pins. They have a common and then 2 pins where the other resistor comes out. We're just going to take a look and see if we have any offset. So if I go to this, we have no offset. We go to this channel, we have no offset. So it doesn't look like we have a problem with shorted transistors. We know we have voltage going to them. We checked the one channel, and this is not a dual power supply or independent power supply for each channel. So we're going to see if we actually have signal leaving this amplifier. I've taken the ground lead that I was previously using in the DMM and just run it right to the ground input of the scope. That way I don't have to have that little probe extended ground wire here which pulls off or doesn't have a convenient place to ground to. The easiest place for us to look for signal is just any one of these emitters. I don't really care where you tap it, we're just looking for absence or presence of signal. So I'm going to tap onto this right here and we look at the scope and you can see we have good signal there. And if I do the same thing on the other channel, we have signal there as well. So we have no gross offsets of any kind, and it's staying in protection, or more correctly, the protection relay is not closing. So we're going to have to take a look at that circuit and see if we have a problem there. Our protect relay is RL101 right here. You can see it just makes the circuit that goes right out to the speaker outputs. And we have good signal going in. So now we need to try and figure out why this relay is not closing. This should have voltage on it on this side, and this should be pulled to ground when Q207 is energized. And it looks like this is not happening, or the relay coil may be open. We need to look at that. So we need to have 0.6 volts at the base of Q207 in order to turn it on and pull one side of the relay to ground. On the other side of it here, we have these two 56K resistors that are coming from the left and the right channel and common up here and feed into Q202. That's where it senses if there's excessive DC on the outputs. Now we already ensured that there wasn't, so this is not a problem. Whenever I'm looking at a circuit like this, then they're all a little different. I just basically look at in and out, and if I need to analyze further, I will. But most of the time, there's no need to. We'll start here. We know that we have a problem, and excuse me, our base is going to be driven positive through here, from here. So we're going to take a look and see what voltages we have here, and if they're not right, and we'll also check the relay here. If they're not right, we'll start going further back until we find our problem. All right, so we're going to take a look at Q207. That's this guy right here, and we want to check the collector to make sure we have voltage going to the relay. So our collector has 0.355 volts. Might help if I actually turn this thing back on. Let's try that again. Okay, we have 41 volts at the collector of Q207. Now there might still be a break between here and the relay, but let's take a look at the base. The base has nothing, and the emitter has nothing. I mean nothing. And right at the relay base here, I do have my 40 volts. So we're going to have to go further back and find out why we don't have any voltage here. So let me find D201. Excuse me, this may take a moment. All right, I'm going to pause this while I find the next components I need to measure. All right, so D201 is right down here, and the anode has 0 volts, and the cathode has 9 millivolts, which is close enough to 0 that we're not even going to worry. All right, so we have voltages that are coming in from here. So let's look at the base of Q201. That's right here. Okay, we have 41 volts at the base of Q201. Q201 is up here. And we need to see what we have at the emitter. And we also have, I believe that's an 620, I don't know. It's a resistor that goes between the base and emitter. And that goes down and feeds R205, a 56K resistor, and goes down. It should provide some voltage to our relay here. To Q207. So I'm going to take a look at 201. We looked at the base, so let's look at the emitter. And we have about 41 volts at the emitter. So we have voltage going to here. Let's look at R205. Now R205 is right down here. I have 41 volts at one side, and I have 9 millivolts at the other. We either have an open 56K resistor, or we have a short to ground either through this capacitor or through the collector emitter junction of this transistor. I'm going to turn the power off, and we're going to see what kind of resistances we have. Now this thing takes quite a bit of time to discharge, I believe. Let's see. Oh, that's dropping pretty quick. We'll wait for this voltage to bleed off. It's going pretty quickly. Incidentally, I made a couple of clip leads with resistors in them for discharging capacitors safely. I think I used 51 ohm, 3 watt, pretty much what I had laying around. Let me just show you those while we're waiting for this to discharge. Basically, I just took a clip lead and cut it in half, and I spliced these resistors in here. And you can put these across a power supply and safely discharge it. I demonstrated to someone why we did this. I charged up a capacitor and I shorted it with a screwdriver. It made a loud crack, ate some of the screwdriver away, and damaged the terminals on the capacitor. It was an old cap. I didn't care about it. I had taken it out of an amp when I rebuilt it. That's why you make these. 51 ohms will discharge it fairly rapidly but safely. No arcing, no damage to any terminals. Well, let's see, how's our discharge going here? All right, so we're dropping, we're less than a volt. So, what do we have to ground? Okay, so this is 12 ohms to ground at the other side of this 56K here. So we have a problem. It's either this capacitor or this transistor. So I'm going to go into diode test mode, and we're going to take a look at that transistor and see if we have a problem. So let's connect the leads back up. I have in the past neglected to connect one of the leads and wondered why nothing worked. All right, so we are looking at 206, which is right down here. That is an NPN, so okay, so that looks good. Okay, so we either have a bad transistor or a bad capacitor. It's a crapshoot. It's going to be a 50-50 shot which one it is. So I may have to pull them both. I'm going to start with the cap, just because you got to start somewhere. All right, so we're going to try pulling that capacitor and see if that's what our problem is. So that guy is right about, I think, here. Yeah, that's it. And always check the polarity when you pull it out. The boards aren't always correctly marked. So I got this guy pulled out. Negative was facing fronts, 220 microfarad at 16 volt. And the meter says it's shorted. So this is our short circuit. And this is why we weren't getting any voltage there. So I'm going to get a spare and put it in, and we'll see if that cured our problem. Let's see. All right. Negative facing the front. So I'm putting in a Panasonic FM series, I believe, whatever. This is not shorted, so that's its claim to fame here. If we put the meter on this, you can see there's no deflection. It acts like a capacitor should act. Negative facing the front. We pop it in, bend the leads to hold it more or less in place, and let's solder it in. I always add just a dab of solder to the tip to facilitate heat transfer, and it makes the soldering go a lot smoother and a lot quicker. You want to put just enough heat on, not too much, not too little. Kind of a feel thing. All right, so let's cut the excess off, and we'll have to see what we get here. All right, I'm going to turn this thing on. Here's our replacement cap right down in here. So let's turn this thing on and see what happens. Now, I can't put it on the dim bulb because these magnetic field power supplies don't play well with the dim bulb. So we're just going to turn it on and hope for the best. I heard a click. Well, let's put some signal in and see if we get anything. Okay, let me turn the noisemakers back on. All right, so here's our scope. Let me turn signal generator on. And we got to put our scope back to 2-channel mode there. And let's see here, amplitude 0.5. Well, that's interesting. Huh. So it's kicking in and out. Okay, if I drop the signal level, it's okay. But it doesn't like having a lot of signal put in. So apparently we have some other problem in here we're going to have to take a look at. Wow. Yeah, I'd say that is some ugly, ugly stuff. Yet at 100 millivolts in, it looks pretty clean. And anything above 200 millivolts, yeah, it just pushes it into this. All right, so we're gonna have to look at this and see what's going on. But something is ugly. Interestingly, it's both channels. So I'm gonna pause this while I think about it. All right, so this has only been on a few minutes, but here's a clue. If we take a look at the temperature of this heatsink, you can see that's reading about 85, 86 degrees. And if we look at the other heatsink, you can see it's about 111, 115. I could feel, 120 in some places. So we're gonna have to take a look at this and see what's going on, because that's not right. Okay, after spending an inordinate amount of time trying to figure out what was wrong with both channels of this amplifier, I decided it might be a good idea to take a look and see if everything was connected right. Now, the speaker outputs on this are a little different than you find on most amplifiers, because this one will do bridge tied load, but usually when you do that you use both the positive outputs. So I want you to take a close look here. So here are black and reds, ground and positive, except if you take a close look here, this ties to the chassis and this ties to the chassis. I don't know how well you can see that graphic there, but this was the problem. Because when I connected both of these speaker outputs left and right to my analyzer, with the black leads here and the red leads here, take a look at what we get. Here's right. Okay, and indeed that is the right speaker, and this is the left. And now let's take a look at my dummy loads and see what happens when I put the meter in ohms and measure them. You have to excuse me, when I'm working, my bench just becomes a nightmare. I have wires and meters and stuff everywhere. So let's see how well you're going to be able to see this. I'm going to have to zoom in a bit. All right. When I measure, I should get 8 ohms, and I do. Look what happens when I measure the right. I get about 1 point, let's see. And that's because of the way the chassis are. So if I pull this out, there's my 8 ohms, and I reverse them back here. Now we have 8 ohms. I can put signal into this now, and it looks good, except of course, one channel will be inverted from the other. So I'm going to put it up so you can see the scope. Okay, I've got the amplifier on, it's clicked out of protection. Let's put some signal in and see what we get. Okay, you can see we have signal on both channels, nice looking sine wave. The right channel is 180 degrees out of phase with the left channel because of the nature of this amplifier. Now when you hook speakers up to this, it's not a problem. The speakers are isolated from one another. The commons of my test set are not isolated from one another. That's why we were having a problem. That's why one side was getting hot, because the right channel was grounded because of the way the speakers are connected to this. Remember, the hot side of the right channel goes to chassis ground. So now we should be able to put plenty of signal in here with no trouble. There's 25 watts. There's 106. And it clips it. Okay. Okay, let's try that again. Okay, I'm gonna have to turn it off and on. Okay, pop the fuses in my variac with that, so let's try this. 2 volts. That gives us 106 watts a channel. So let's try 2. Okay. I am going to have to take this out of my variac because it's already pulling 12 amps. These Carvers are supposed to take the power they need right out of the outlet. So let's see if I can trip the breaker right from my bench. Okay, I bypassed the variac, so let's try this again. 2.5 volts. .5 volts. There we go. It's 170. 2.7 volts. Okay, we're pulling 16 amps. I'm going to trip the bench breaker. But anyway, the amplifier works now that I discovered the error of my ways. I had never seen speaker outs like that, but the positive of the right channel goes to ground. Once I flipped them, we were good. And like I said, if you're using speakers, it's not an issue. So anyhow, I spent quite a bit of time chasing a trouble that I actually didn't have. These things happen. It's a learning experience. This is why some people specialize on certain makes of amplifiers. It just makes their life easier. They get familiar with them. They carry a certain amount of parts. Excuse the noise. I have the garage door open. It's a nice day. But anyhow, our only problem was a shorted capacitor in the protect circuit. So the amp's now fixed. I'll just check the bias. There's no offset because this is a servo amplifier. And once that's done, I'll put this together and move on to the next project. Anyway, I enjoyed making this video. I enjoyed pulling my hair out trying to figure out what the problem was. But I eventually figured it out. As I often say to people, I'm not the world's greatest tech. My only superpower is I simply refuse to give up. Anyhow, I hope you all have a great day. And as always, I like giving back to the community that has given me so much. Thanks a lot, folks.